Okay, so first of all, my name's Miss Crase. Miss Cortney Flannery kid is not here today because she just had a baby. So she's at home with her 3-week-old little baby boy. And I'm going to be honest up front, this is her grant. This is not my grant. I teach math, and this grant is biology. So bear with me when I go and present this. I'm going to be doing a lot of reading, and I would love to explain all this to you, but I can't. So if you have any questions, I'm sure if you'll email Miss Courtney Flannery Kidd, she will respond to you as soon as she can, okay? So her grant plan is to implement strategies that promote a progression of skills that allow students to use models in more of an evaluative way that allow them to predict and show relationships between variables in life science. So she's pulling from the next generation science standards, and she recognizes that her students have some issues with modeling, okay? So modeling will be used in a capacity where her students will not only look at paper model systems, but it will allow them to experiment in ways that let them develop their own mathematical models, illustrations, systems, or data sets. And she's going to do this by utilizing 4 different activities that focus on a couple of her different areas in biology. So one's going to be in biochem, one's going to be in genetics, and another one in ecology. So the first activity, she's going to let students use model water molecules to explore and understand polarity, hydrogen bonding, surface tension, solubility, states of matter, and structure, okay? So during that activity, students will they'll model, and it'll consist of powerful magnets that are embedded in atom sensors that allow students to see and feel their molecular attraction or repulsion, okay? This will allow students to more easily grasp and comprehend fundamental molecular interactions in biochemistry. Again, I would love to explain that to you, but if you're science people, I think you know it. Us people who are not science, I'm sorry. Okay, activity number 2, students will be introduced to an enzyme catalyst lab that will allow them to explore interactions of enzymes and substrates through a hands-on activity that will help them model enzyme kinetics. All right, in activity 3, students will be using direct counting to model and then calculate the allele frequency of traits using stem and leaf types in a population of Wisconsin fast plants using constant light bank. And then her last activity is going to be students will depict and analyze various real-world impacts such as population and habitat loss. Okay, so her 4 activities will focus on how students can use modeling to pretty much increase their science knowledge when it comes to math and biochem, genetics, and ecology. Okay.